Hi guys, here's your video going over partial fractions day 2. So day 1 looked at partial fraction decomposition with quadratic factors and linear factors. For this video, we are going to look at what happens when our degree of the numerator is greater than or equal to the degree of the denominator. So if you recall, your degree is your highest exponent. So if I look at this, my degree is 3. And if I look at my denominator, my degree is 2. So my degree of my numerator is bigger than the degree of the denominator. And so when that is the case, you have to do one extra step before you can start the process of decomposition. And that is to use long division first. So we need to actually divide these polynomials first, and the way that you can divide polynomials is by synthetic division or long division. But since this denominator has an x squared, that means we're going to have to use long division. So just a little refresh on long division. My denominator is what is going to go on the outside of my long division bar. And on the inside, I'm going to put my 2x cubed minus x squared plus x plus 5. And now I'm going to go through the process of dividing these two. So I'm going to look at my first term, that x squared. I need to ask myself what times x squared gives me 2x cubed, and that is 2x. So I'm going to put that right on top of my x term because I like to line up my terms for organizational purposes. And whatever I put on top, I'm going to multiply all three of these terms by it. So 2x times x squared is 2x cubed. 2x times 3x is negative 6x squared. 2x times 2 is 4x. Once you have that, you're going to subtract. But since we're dealing with polynomials, I always like to say draw the line, change the signs. And then we can combine. And that gives us negative 7x squared minus 3x. And then I'm going to bring down my next term, plus 5. And then the process repeats itself, so I need to figure out what times x squared gives me negative 7x squared, and that is negative 7. So I'm going to multiply all three of these by negative 7, so negative 7 times x squared is negative 7x squared. Negative 7 times 3 is negative 21x, and negative 7 times 2 is negative 14. I'm going to draw my line, change my signs. And that gives me 18x plus 19. Now this 18x plus 19 is your remainder. So I would take that and add it to my quotient, which is the 2x minus 7, plus 18x plus 19 over what I divided by, which was x squared plus 3x plus 2. Now that we've done the long division, we can look at this remainder over here, and that remainder you can break apart further using partial fraction decomposition. So we're going to kind of ignore that 2x minus 7 for now, and we're going to work through the decomposition of the 18x plus 19 over x squared plus 3x plus 2. So I'm going to go ahead and rewrite it on a fresh slide. So let me rewrite this. So I have 18x plus 19 over x squared plus 3x plus 2. Now going through the partial fraction decomposition, I'm going to start by factoring my denominator. Two numbers that multiply to 2 and add to 3 are 2 and 1. So I have x plus 2, x plus 1. And so once again, those are going to be my denominators for my two fractions. So my first one's x plus 2. My second one is x plus 1, and it's the numerators that I don't actually know what they are, so I'm just going to leave them as variables a and b. And then from here, I want to add these two fractions together, so I would take my first fraction and multiply it by x plus 1, since you need a common denominator. I would take my second fraction and multiply it by x plus 2 to create the common denominator. Now again, I'm mostly focusing on the numerators because that's what I care about, that's what I want to solve for. So I'm just going to rewrite this with just the numerators. So I have a times x plus 1 plus b times x plus 2, and that is supposed to equal my original numerator, which is the 18x plus 19. From here, I'm going to distribute my a's and my b's. So a times x is ax, a times 1 is a, b times x is bx, b times 2 is 2b, and of course that is supposed to equal the 18x plus 19. And then from here, I'm looking for like terms, so I'm going to look at my x's. I have ax, bx, and that is supposed to equal 18x. So that's going to set up my first equation for my system. A plus b equals 18. And then I also have a plus 2b. Those are going to be my constants since they don't have any x's, and that's supposed to equal 19. So a plus 2b equals 19. And then we just have to solve the system. So you have a variety of methods that you can use to solve the system. You can solve by substitution, you can solve by elimination, and you can use matrices if you want to. I'm actually going to use matrices because I happen to find that those are a lot quicker. So I'm using that reduced row echelon form that we have in the calculator. But again, you have a variety of methods that you can use, so it just kind of depends on which method you prefer. So going through the reduced row echelon form on my calculator, that gave me the solution 17,1. So A is 17 and B is 1. So now I have my A and my B, I can write my final answer. So my A was 17, so I have 17 over x plus 2. Plus b is 1, so 1 over x plus 1. And don't forget that this was just the decomposition of this piece right here. And that wasn't the full original problem, that was just the remainder. So looking back at this, I still need my 2x minus 7. So now I'm going to go back and I'm going to add that 2x minus 7 in front of my two fractions. And there is your final answer. So again, if your degree in your numerator is greater than or equal to, this example was a greater than problem, but if it were or equal to, you would have to use long division first to break it down further, and then whatever your remainder is what you are going to use to work through that partial fraction decomposition.